Welcome to today's webinar, Strategies for Small POTWs Handling High-Strength Influent. Today's webinar, which is a continuation of the June 17th webinar titled When Small POTWs Should Establish a Pretreatment Program, will cover non-compliance problems caused by pass-through or interference from industrial users that small POTWs may encounter and what they can do to protect their plants and personnel. The speakers today we're lucky to have, and I've known both of them for a very long time, Justin Parr, the EPA Region 1 Boston office. Justin works in the Municipal Assistance Unit and is the Regional Pretreatment Coordinator for the 6 states within the EPA New England Regional Office. Jay oversees and coordinates all pretreatment activities throughout the region, has played an integral role in providing technical assistance to wastewater treatment plants related to emergency response and pretreatment program implementation issues. Prior to his position as regional pretreatment coordinator, Jay was multimedia investigator for EPA's Investigation and Analysis Unit and EPA's regional laboratory. Jay has been involved in the pretreatment program since joining EPA in 1993. And we also have Al Garcia, who served as EPA Region 8's pretreatment coordinator. Region 8 is located in Denver, Colorado. Before coming to EPA, Al worked at a local municipality and has significant experience providing regulatory controls to industrial and commercial facilities, including sampling, inspections, permit writing, compliance evaluation, and enforcement. Al has direct implementation responsibilities for the pretreatment program in Colorado, Wyoming, Montana. He has also oversees state authorized pretreatment programs in Utah, North Dakota, and South Dakota, as well as oversight of the Colorado MPDS permitting program. During the question and answer session, we will also hear from Jan Pickrell, who and Rebecca Christopher, who is Jan is the National Pretreatment Coordinator.
Thank you, Peter, and thank you to headquarters for putting this workshop on. I'm pleased to be able to present today. And thank you again for headquarters for putting this together. This topic today of dealing with high strength organic waste is one that I basically dealt with for my 27-year career at EPA, doing inspections, etc. So I'm glad we've had the opportunity today to provide some guidance and training on the issue. I want to make note here that this is guidance and a little bit of training. We're not here to set EPA policy or regulations. Seeing there's 1,300 people registered, that is completely awesome. I hope that this is a worthwhile hour and a half for you, because you'll never get it back. Good afternoon for those that are on the East Coast, late morning for you on the West Coast. And thanks for Seth Hemingway who wrote me into giving this presentation after I gave a similar talk at the NPDS Basic Inspector Training last December, but he's not here today. And I'm pleased to share the stage here with my good friend and colleague in Region 8, Al Garcia. The last time we shared a stage pre-COVID, I think it was karaoke after a brewery visit, one or two. So Al's going to provide some insight on the second part of this presentation. As far as Q&A goes, please feel free to put any questions you want in the Q&A box there. We will not be taking questions on the combined waste stream formula, etc. This is not a stump EPA question, but feel free to put in anything you want in there. So hope you enjoy this session here. Today's focus is going to be on breweries and dairies. I don't have any slaughterhouses here in New England, so I'm going to focus my talk on the breweries and dairies. But really, when we start getting into BOD, TSS, conventional pollutants, all these case studies, etc., it could be a dairy, it could be an ice cream manufacturer, it could be a slaughterhouse. So I'm just going to focus on some good old-fashioned beer and milk here. So specifically, I'm going to give you a little bit of a background on high-strength organic waste. We're going to talk about a couple of case studies. Al has some great case studies, and Al's going to talk a little bit more about the operational aspects of the treatment plant, while I'm going to give kind of a little overview, strategies, permitting. Somebody said, please don't talk about P2. It's the most boring subject around. So to get around P2, I'm going to show you a 7-minute video that talks about side streaming. If we were live here, I'd ask everyone to raise their hand if they've ever heard about side streaming. So it's a great tool in place for the breweries to side stream some of their solids waste. And again, I'll show you that video. When to permit, some permit examples, then we'll talk a little bit about local limits development. But this training is really specifically for the smaller POTWs and how they regulate or provide oversight. I hate to keep using the word regulate, but there needs to be some form of oversight of your industrial users discharging this high strength waste to the collection system. And I know for some of the small programs where you have one industry discharging into a small program, and I say small, like, less than 1 million gallons a day, or maybe less than 2 million gallons a day with a large industrial user of several 100,000 gallons. It may not be easy. You may have family members working at the plant. You may have close connections to the plant. You may have worked at the industry over the years, but really, the industry has the potential to cause pass-through and interference at your POTW. So you need to take all precautions in order to protect the treatment plant. Remember one thing, the P in POTW stands for public and not private. No industry owns the POTW. The industry may pay operational costs at the POTW, but they do not own the POTW, and it's a privilege to discharge to the sewer system and no one's right to discharge. And if they're given a permit and they're given that right can be taken away at any point in time with the termination of a permit. Or you can take it to the extreme. If you want to back up a concrete truck and fill the manhole with concrete, that's another surefire way to stop the discharge into the sewer system. Again, taking the extreme. So if there's nothing else you learned today, I want you to remember one simple thing. And here it is. If you switch to Geico, you too could save 15%. All right. Being serious here, this really presentation is not to tell you what you must or must not do. It's just to provide you with some insight in order to help you better understand the impact of your industrial users on your system. It's your decision on how you handle or provide the oversight of the system. And again, we're not here to create policy. My talk reflects my personal position and not necessarily reflective of EPA's position. So, get a couple little background slides out of the way here. Is the discharge a significant industrial user? Well, for most of the audience, and hopefully all of the audience, you've seen this about 4,000 times right now. Is the industry subject to categorical pretreatment standards? Ironically enough, the industries we're talking about today, dairies, they're subject to 405, fruits and vegetables, subject to 40 CFR 403. Maybe there's a seafood processor, 408, feedlots, 412, and the slaughterhouses fall into 40 CFR 432. However, when you go back and look at all those regulations, although there may be an effluent guideline for that particular industrial sector, neither of those actually have pretreatment standards. So technically, they're actually not subject to the categorical pretreatment standards, even though they meet the definition. Okay. So then we jump to this 25,000 gallons per day. I typically tell people to just throw that right out the window. You've got industries that discharge at 20,000 gallons a day, which is obviously less than 25,000, but yet they have a heavy load to the treatment plant. So throw the 25,000 out in most cases. And also the third one here, the 5% of the hydraulic or organic loading. I was talking to someone the other day about this, and they said, well, they only discharge probably 3 to 4% of the organic loading at the POTW. And I said, okay, well, that's great. They don't meet that definition. But how many other breweries in town also discharge 3 or 4%? And so if you have 5, 6, 7 breweries that discharge, or dairies, or any high strength waste dischargers, multiply that times 3 or 4, and you're upwards of 30% of the organic loading at the treatment plant is made up of industries, but you choose not to regulate them or provide oversight because they technically don't meet this definition of 5%. So that brings me down to the catch-all in the bottom here, which is where most of the industries within New England fall under as far as why they're designated as an SIU, is that they have reasonable potential for adversely affecting the POTW's operation. So regardless of SIU definition, which is really hard to ignore for an approved pretreatment program, for those of you in the non-approved programs, and I would assume we have a lot in the non-approved programs, again, you need to provide some form of oversight of your industrial users, whether it be an agreement, a permit, BMPs, etc. There needs to be some form of oversight. Okay, so and if you feel like you're a POTW in a smaller program or a larger program, and you don't have any issues, listen to some of the case studies that may open up your eyes here. Don't just go whistling past the graveyard here and thinking everything's okay. Get some skin in the game and be proactive with your industrial users. Some more pre-treatment background, and I promise I'll get off the 403 kick here in a few minutes. First thing that comes to mind when we think about SIUs is permitting, inspections, and sampling. Again, you don't have to provide that inspection, sampling, and permitting of all industries, but if you don't, you're really kind of behind the 8 ball. All right, I'm done with the 403 references and slides now. If I show another slide or reference 403 here, just reach right through the screen and just punch me right in the face, okay? Please do that. Regardless of whether or not they are a significant industrial user, the specific prohibitions all apply. And I'm not going to go through these. You know where to find them. Bang, back in 403. Again, all industrial users are subject to the specific prohibitions. So the $1 million question here I get all the time is, should I permit this industry? And my very simple, easy response back to them, and it's very sarcastic, is to say, how the heck should I know? You just asked me, you just told me, should I permit the brewery, or should I permit the dairy, or should I permit the slaughterhouse? So the long answer begs to go back to many questions, which I don't know. So I start to pose to the POTW. And first and foremost is, what are the BOD and TSS concentrations at the industry? Do you know that? And they usually say no. Okay, so I say, well, if you don't have any data on them, what are they expected to discharge? So these are questions that you need to ask yourself. Do they have a brother or sister facility across the state or somewhere else where you could use as a baseline for some of the loadings? Have they ever sampled them? Have they ever submitted any monitoring data or any information as to the characteristics of the waste stream? Have they submitted a permit application to identify any other waste streams? Do they have any P2 measures in place? I can go on and on and on. Does the industry have any wastewater treatment in place? And if so, is that acceptable? If you do have any data on the industry, is the industry complying with your industrial local limits? Do you have local limits? And then, once we get off that kick, I start asking them, well, how about the POTW? How are they performing? Can you handle the loading that this industry is going to give you? Okay, are you meeting all your NPDES permits for your conventional local limits? More importantly, are you approaching 85% of the design capacity at the treatment plant? Because guess what happens when you reach 85% of the capacity? That triggers the city to develop a facility upgrade plan. And I'm finding now that most of the design loadings are very underestimated, okay? They're taking design loadings based on BOD of 250, 275, 225. One could argue that all day. Make sure your design loading at the treatment plant is accurate, okay? And then lastly, for the smaller programs and non-approved programs, do you have the authority to actually issue permits? That's the $1 million question as well. I don't know that. So lots of questions to ask yourself as you go on here about all of this. And some of we went through a lot of this as well. I hope that if you are not permitting your facility, your particular high strength waste facilities, you're at least surcharging those facilities. If that's your course of action that you choose to take. Again, what does it cost for you to remove 1 pound of BOD at the treatment plant? I don't know. That's for you to answer. Your 20, 30, 40, 50 million gallon treatment plants probably don't have any issues with that. Good for you. But let's assume it's 5 cents a pound or 5 cents a gallon, whatever unit you want to call it. You need to recoup those costs, those operational costs at the POTW. You charge the septage haulers roughly what, 5 to 10 cents a gallon to dump residential waste at a BOD of roughly 250 milligrams per liter. Why not charge your high strength waste facilities if you're not going to be permitting them? Okay. These are rough numbers. Really don't pay any attention to these numbers at all. I just wanted to throw that up there to give you some rough numbers of what BOD concentrations may look like. One could argue this all day long. Someone could say whole milk, well, it's really only 50,000, maybe it's 150,000. Beer is all over the place. You know, let's not argue with the numbers. Really, the slide is just to show you that the concentrations are in the tens, if not hundreds of thousands of milligrams per liter, okay? But typically what you could expect from a high strength waste discharger on average with good BMPs in place, roughly 2,700 milligrams per liter. But again, that's going to be all over the place. What are your impacts to the wastewater treatment plant, the infrastructure, et cetera? You know this better than I do. High influent BOD, TSS, the process upsets, odors at your facility, increased costs. That's the huge one right there. How about the blowers in the aeration basin trying to keep the DO levels down? Electricity is the #1 cost at the treatment plant. And then last, but certainly not least, the possible NPDES permit violations. My kids have been watching Ghostbusters all weekend long, so tribute to them. I sit here and say, who are you going to call? EPA enforcement, because that's what happens, right? EPA enforcement is going to come, or the state is going to come down on you. When you violate your NPDES permit, chances are, unless it's directly impacted to the industry on a potential pass-through interference, they're going to come after you. I thought I'd throw the slide up there. I got this about a week or so ago. This was a recent case where a creamery in Myrtle Point, Oregon, took me forever to pronounce that. Apparently it's not Oregon, it's Oregon, pleaded guilty to 4 counts of violating the Clean Water Act. I thought that was interesting. I wanted to share with you. Valley Crest Foods here was regularly discharging wastewater to the sewer system that caused disruptions at the POTW. The creamery processed raw milk, turned it into finished milk product. They had clogs in the lines. Occasionally when the clogs, they would drain these clogs and slug loads would go to the POTW. The facility was regularly discharging these slug loads that interfered with the disinfection process at the treatment plant, causing elevated bacteria levels to no one's surprise, violating the NPDES permit limit, and apparently on several occasions, the level of bacteria in the river was enough for the public service announcements to basically say, avoid the river altogether. And ultimately, the facility pleaded guilty to 4 counts of violating the Clean Water Act and had to pay a fine of $20,000 per violation. So, quick case study here. This is Charles River Water Pollution Control District, and they're in Massachusetts. Somewhat older photo, but great time of year here. We have lovely foliage in New England this time of year. There are a 5 MGD design plant, so obviously the flow is a little less than that. And I want to give, and I'll circle back to this, full kudos to the wastewater treatment plant, or I should say the district, for the way that they handled this situation. They had the executive director and the pre-treatment coordinator were both expecting newborns at the time. And I think the executive director may have actually even been home on maternity leave during all of this. So it was very unfortunate timing. The POTW has your traditional NPDES permit here. I'd throw that up there. Types of industries, they had 3 SIUs. The big one here is the dairy. I was asked to leave the dairy's name out, so I will and respect that. They also permitted other industrial users there, quite an array of users, but really the dairy was the one they were concerned about. And ironically enough, before this incident happened, I went out and did an audit, and I actually, the region awarded the district an individual pre-treatment program for honoring them for excellence in the program, because they actually had run a stellar program. And although I don't remember it, it was brought to me after the coordinator said, you know, when you were here, you said we didn't have BOD and TSS limits and we should probably develop them with the dairy, but we really don't have an issue with the dairy, so we'll just go status quo for now. So anyway. They didn't have any current conventional sewer use, conventional limits in the sewer use ordinance. They did have this language about the following discharges at the facility are specifically prohibited. It talks about BOD, etc. And here's some more information on the industry. It's about 450,000 gallons a day they were permitted for. And note here, they did have an old standing CBOD limit in the permit for years and years of 2,000 pounds per day as a daily max and 1,000 pounds per day as a weekly average. So they did have a permit limit for CBOD. This is an interesting slide because this is the dairy production that went to wastewater went to an equalization tank, anaerobic digester, re-aeration, and into the sewer system. But you see, they had the capability of going to this bypass valve and then directly to the sewer system. So that's always something to look for, and that kind of was an escape at the end of the day here due to the circumstances. But when you're doing inspections, you should also look for that, follow the sewer lines. So timeline of events. Back in August of 2018, this particular industry, a dairy, had an identical plant across the state of Massachusetts that closed and decided they were just going to move all their operations to another plant, probably an hour's drive away, but decided they weren't going to tell the POTW. So almost immediately, the district started to see an impact at the treatment plant, high influent loadings. District put them on a compliance schedule. Again, this goes real fast. Within a month, the industry had issues with the pretreatment system. They couldn't keep up with everything. To no one's surprise, there were odors coming from the complaints from the residents. The Mass DEP went out there and did an inspection and noticed that the digester had settling and gas buildup problems, etc. The industry immediately requested to open the bypass valve for up to 3 days, which would have essentially bypassed all treatment and sent raw dairy waste right to the sewer. In the district, good for them, said, hey, we can't handle this untreated wastewater. No way. That's your problem. If you can't handle it, you got to find a way to treat it. So it didn't take very long. 2 days later, the gas digester membrane ripped, causing the sludge to overflow the tank and requiring them to unfortunately go to full bypass and send the raw dairy to the district. And here's a picture of about 167,000 gallons of wastewater from the digester that was released following the cover rise of 6 feet and the obviously subsequent tear. So got in a big trouble here from the DEP. Why did this happen? Well, obviously many reasons. The first, the industry started processing this heavy whipping cream that used to be at the other facility, increasing organic loading to the pretreatment system. The current system was not equipped to handle it. Ironically enough, the equalization tank was offline for maintenance at the time, so all wastewater was sent directly to the anaerobic digester, didn't have a chance to equalize, mix, lost that buffer ability, and they didn't have any training at the facility. They were just used to handling just simple dairy waste. The dairy staff didn't notify the pretreatment operator of any of this, and obviously the membrane tore. So the impact at the treatment plant, the aeration capacity was maxed out. I put the dollar signs in there. That's huge. Again, we go back to the increased cost at the POTW. The district was also wasting from the primary and secondary clarifiers, had to send off extra sludge disposal, extra trucks, added chemical, ferric chloride, and hydrated lime. Cost. Surprisingly enough, the district was able to maintain compliance with this NPDES permit through this entire process, even though the BOD was at 148% of its design capacity. And as you see from the slide here, the industry alone was exceeding the district's design loading. So goes back to just show you about the design loadings and whether or not they're true and accurate. But really, the only reason they didn't violate their NPDES permit was because it was in the November, December timeframe. Had it been in June, July, August, they would have had more stringent summer limits and probably would have violated those limits. So anyway, quickly, the district amended the permit to reflect the new sampling location and a bypass valve. The industry received approval to start adding hydrogen peroxide, aid in the DO consumption, etc. And through this whole thing there, they had 76 industrial permit violations during the period of November to January, and notification violations there as well. And I'm going to go a little faster through this because I want to get to some of the other stuff. Ultimately, there was a settlement. The key thing to note here is that there were 72 permit violations at $5,000 per day per violation. The POTW had in its sewer use ordinance language which stated they could discharge up to $5,000 per day per violation. And they decided that they were going to go full bore with that, not take in $1,000, $2,000, $3,000, but go to the full $5,000 per day per violation. So 72 violations times $5,000 came out to $360,000, and they had a final settlement of $215,000. So There was tireless enforcement here with the POTW. They relied heavily on the permit, the SUA use ordinance, the enforcement response plan. They used EPA and Mass DEP as assets. Another take-home message here for smaller POTWs is to continue to work with your enforcement staff, your city, town attorneys. You don't want the first time that you're meeting them to be when you have an enforcement action. Get familiar with them. And of course, there are many actions that were taken as a result of this industry. Now, within the past year, the POTW has developed and has obtained approval for BOD, TSS, phosphorus, and ammonia, added certain provisions into the IPP permit. And again, I want to give full kudos to Kristen Liz out at the Charles River District. This was a very unfortunate incident. They handled it very well in a very timely manner. Totally unexpected. They were going down uncharted waters with this enforcement action, handled it very well, and got a $215 settlement out of them within a matter of months. So kudos to the district staff out there. And many lessons learned here, as you can imagine. So what's the big deal with breweries? I want to switch direction here, going from the dairies over to the breweries. Well, I'll show you this quick little video here. I don't think you're going to hear the sound, but I'll play it through anyway. You can read the caption here. Good friend of mine out in Colorado, Kurt, thank you for sending this out. Much appreciated. Sent this out to me. This is public information. This is no insider information here, taken straight from the facilities brewing company from the web page there. And I think there are many take-home messages here. This particular industry was so concerned about making good beer. They said, it brings a tear to my eye every time we watch this. It's better to dump than serve crap, though. I've watched this like 5 times and I'm still chuckling every time I see it. I think, again, when you look at this, you have to say, who's the public relations person for Grist Brewing Company over there? I'm pretty sure that the facility was totally unaware that maybe one day some guy from Boston at EPA is going to be showing this video over a webinar to over 1,300 people about how I'm dumping raw beer down into the sewer system. So I hope that they had effective pre-treatment in place. I hope that that wasn't sent to the POTW directly. I hope that the POTW didn't experience any pass-through interference. But it really highlights the need for education on these significant industrial users. I would never want this to happen at my treatment plant. And again, so I ask you, going back, should I permit the breweries? Well, if I have raw waste coming down my line of roughly 100,000 milligrams per liter, I think I'd probably want to regulate them, because there's always the potential for pass-through and interference. And here's a clear example about this is probably coming from one of the fermentation tanks, and it's gone through the full process and probably tasted like crap, as they say, as I'm quoting them here. And rather than put that in a bottle and serve that, or a keg or whatever it may be, they decide we'll just dump it down the drain and forget about it. So I'm not going to get into the step-by-step process here about brewing. I just did want to give you a little bit of a flavor of how the process works. Most of your side streaming, et cetera, is going to come from the mashing operation. That's where the milled grain is mixed with hot water in a large vessel, commonly referred to as a mash tun, where it's converted into like a sugar-rich liquid or a wort. The wort is then strained off. Then you have boiling. The wort is moved over to a larger tank known as a kettle, and then where it's boiled again with hops, sometimes you'll add some other ingredients like herbs or sugars, and then it's over to fermentation and ultimately packaged and hopefully not dumped down the drain. And here's just really a slide to give you a flavor of where some of the high strength waste might be coming from during a brewery process. And again, this is from brewery wastewater. I want to put a few slides up here to show you where we are with respect to the high BOD concentrations. Beer, 75,000 upwards to 180,000 milligrams per liter. With side streaming, it's a very effective way to knock down that BOD, and mainly the solids. Look at the solids level that come way down. BOD too, but it's really the solids. And I have some, this is data from Warwick, Rhode Island. Thank you, Betty Ann, who sent this over to me. This is real data from a real POTW. You see the pH numbers there, fermentation, wastewater results. Again, this is not going to the sewer system, but this is basically beer that is in process and sampled for BOD, but tells you that in the event that it were dumped to down the sewer, that's what the numbers would look like. Again, BOD, CBOD, 50,000 to 90,000, very, very high numbers. And I know we're getting low on time here, but I do want to show this video because I put this to, I worked with a couple people at EPA. Thank you, Chris Beeling and Marco Rivera, who helped out with this video. And it's a video that was put together about a year ago now. And Laura, if you could get ready to load that up, that would be great. Whereby we went out to 3 or 4 breweries. It was probably one of the best weeks of my life ever working at EPA. And hopefully I'll tell you to turn the sound up here. And we put together this 7-minute video. They say the camera adds 20 pounds to your face, and I certainly don't disagree with that after watching this several times. But it's really a great video on side streaming, okay? And getting that waste out of your tanks, etc., in strategic ways, and also effective wastewater treatment. And I'm going to show you some examples, particularly the Alchemist video or process where they get down to incredibly low numbers. So Laura, if you could just play this video, that would be great.
Available capacity to handle high-strength wastes. Many cannot accept a large amount of brewery waste and still provide needed treatment services to the rest of the community.
The municipal wastewater treatment facility is crucial in protecting Vermont's surface waters. They're the one receiving and treating this wastewater and discharging it to the river itself. So food and beverage manufacturers can indirectly impact Vermont's surface waters if they adversely impact the wastewater treatment facility.
Our wastewater, our effluent from the brewery goes to the Stowe wastewater treatment facility. They discharge to the Moscow River, which leads into the Waterbury Reservoir, which discharges into the Winooski River, which goes directly to Lake Champlain. So even everything that we do here, we feel is part of our responsibility for the health of Lake Champlain.
So when you're designing a brewery, one of the things that a lot of people kind of step over is wastewater generation. You know, for us being in South Burlington was important because this is where our community was, this is where the brewery started, this is where our roots are.
Wastewater facilities, the way I look at it, is a resource. If we have a facility that's discharging into our treatment facility, but they're not using best management practices, they're utilizing a portion of our facility that could be used as a resource for another facility to come in.
When we first started, we didn't do anything. We just put everything out in the drain. That came to an end quickly when the local sewer treatment plant was in trouble.
The brewery industry has become a fast-growing sector, and EPA is encouraged to see that many breweries have adopted best management practices in order to control high-strength organic waste from being discharged into our municipal sewer systems.
And we're just careful about a real culture of trying to use as little water as we can. No beer goes down the drains. We recycle all the cleaning chemicals that we use, so we use them over and over again. Big bulk that's left over from the brewing process, of course, is the mash. When you take spent grain out of the mash tun, we load it into a trailer. It gets picked up on Fridays, and then goes to a dairy farm for the milking herd of some local farmers. Other parts that are left over is the yeast and also some of the hops that cows just don't like. So we put those in totes and we bring those to a local composting facility right in town here.
Scott is describing side streaming. Side streaming keeps processed waste separate from wastewater. The wastes are then reused or more efficiently managed. BOD, or biochemical oxygen demand, is a measure of the organic content in wastewater. An average American household produces wastewater that has a BOD of around 300 milligrams per liter.
Just before we started all of our side streaming at our Waterbury Brewery, our BOD load going down to the town of Waterbury was about 20,000 milligrams per liter. after really working on our side streaming and getting as much out as we possibly can, we average around 1,500 milligrams per liter. And that's strictly just side streaming, being very crazy about catching every drop of beer, all the yeast, everything we can. We catch it and get rid of it beforehand.
Side streaming sometimes solves one problem, but creates other challenges.
So side streaming was a great process for us, but the amount of waste we were generating would necessitate a truck coming to pick up the rollaway tank every 6 to 7 hours. And that was just for our liquid waste. So when you add on another truck coming to pick up your spent grain every 8 to 12 hours, you're getting 4 to 5 trucks a day in and out of the brewery every day we were in production. So as production grew and that traffic flow was increasing.
Chris solved his process waste problem with an anaerobic digester. Anaerobic digesters make meticulous side streaming less important because all high-strength wastewater goes to the digester where bacteria convert the organic material in the waste to methane gas, which can be used for heating or electricity. The pre-treated wastewater is then sent to the municipal wastewater treatment facility.
So the anaerobic digester provides a number of benefits, not the least of which is a business benefit for us. We're able to eliminate the trucking cost of side streaming all of our waste, and we're able to cut our electrical costs by 60%. So those net up to a big savings for the brewery. Spent grain can be hauled away and used as feed supplement for local animals and farms. And the dewatering process of the digester also creates a wonderful nutrient-rich fertilizer that we can then use for local farms as well.
Bioreaction, sometimes called aerobic treatment, is a more traditional means of treating wastewater. It works by providing oxygen to microorganisms to help them break down organic wastes. It can also help remove phosphorus and other pollutants. The Alchemist uses this type of system in Stowe, Vermont.
At our brewery here in Stowe, we practice all the side streaming that we do at our Waterbury brewery, with the exception being that we have an aerobic bacteria digester here in Stowe. So the digester needs a certain amount of BOD and strength coming through to support the aerobic bacteria. So there are certain points along the line in Stowe where we don't practice the same extreme side streaming as we do in Waterbury. So our effluent coming into our wastewater pretreatment system will run about 4,000 milligrams per liter BOD. And by the time it's leaving the wastewater treatment system and going to the town of Stowe, it's down to about 0.2 milligrams per liter of BOD.
That's over a 99% reduction of BOD. 0.2 BOD is about 1,500 times less than an average household discharges.
As far as the BOD levels go, the town's wastewater treatment system is getting surcharges or just disposal charges of over $80,000 to $100,000 a year because of our discharge, which they were happy to share with us. And so we were paying $80,000 or $90,000 a year.
So Scott began to side stream, but he still had to pay $60,000 to $70,000 a year in surcharges. He then invested in a pretreatment system and eliminated the surcharges.
We've been able to get the BOD levels down to under 300 consistently, sometimes under 200. So the system will probably have about a 6-year payback for it.
In addition to high BOD, breweries can discharge large amounts of phosphorus, leading to harmful algal blooms and low oxygen levels that can harm aquatic ecosystems.
We're having a real issue in Lake Champlain, our large lake, with algae blooms, and a lot of that is contributed to excess phosphorus. So our system here, we're removing 96% of our phosphorus load before it goes down eventually to Lake Champlain.
Pretreatment programs work to regulate breweries and other food and beverage processors and ensure their wastewater streams can be safely and effectively treated by the receiving facility.
The pretreatment program relies on partners to reach any entity producing high-strength waste or discharging high-strength waste. And we use partners such as the DEC's Environmental Assistance Office, the Vermont Rural Water Association, and the EPA, and municipalities.
Craft breweries find themselves in the vanguard of an entrepreneurial environmental movement in Vermont, New Hampshire, and around the country. They are reducing their high-strength wastewater while finding markets for their waste products. These breweries then help keep America's surface waters clean while providing their unique innovations on an American tradition.
Wonderful. I hope you enjoyed that video. It was truly a pleasure to make. Thanks to Nick Giannetti from Vermont. I know you weren't ready to do the interviews on that particular day, but thanks for taking one for the team and answering those questions. So, hopefully that video answered a lot of the P2 measures there. Again, side streaming, it's collecting high strength concentrated waste at the source and just setting it aside for disposal. And those solids and spent grain may be used as cattle feed as described, just not hops. Cattle don't like the hops, don't send the hops out to the cattle. But again, and a lot of dairies or breweries, etc., particular breweries here, can recoup some of the cost because you can actually sell off some of that solids and spent grain because again, the farmers love it. I want to pay close attention if you caught it from Alchemist. The influent BOD going into the pretreatment system at the facility, at the industry, at the brewery, is 4,000 milligrams per liter. Going out, it's less than 0.2 milligrams per liter. By show of hands here, and I don't think I'll see many, if any at all, how many POTWs can say that your effluent is less than 0.2 milligrams per liter? None. I bet there are very few, if any at all. If you're a POTW and your BOD is less than 0.2 milligrams per liter, put it in the Q&A that you're in there. I would like to know, because that is truly remarkable. Okay, so brewery wastewater makeup, what is it really made up? What are we really talking about? It's the cleaning of the tanks, equipment, and the floors. Most of the wastewater coming from the brewery operation is going to come from the clean in place, otherwise known as the CIP process. Typical CIP process is a hot water rinse and it could be all of these tanks we're talking about, the mash tun, the kettle tank, the lautering, the fermentation tanks, all of those tanks. With FDA, et cetera, need to have extreme cleaning measures in place. So hot water rinse, followed by typically another hot water rinse with a caustic. That's where the high pH comes in. You'll have another rinse with a sanitizer. That's your acid. You have another low pH. And then since it's low, you need to hit it with another caustic on the other end. So you're getting these fluctuations on the high and the low pH, in addition to the leftover BOD and solids and the organic loading that's there. Okay, so here's just a little chart I wanted to show you that shows you the fluctuation of pH from the brewery. This is without treatment, without neutralization. As I said, depending on the clean in place process, if you're cleaning a tank with a caustic and then that's just going dumped right down the drain, then you're going to have a high pH, and then you hit it with a sanitizer, an acid, and you're going to have a low pH. So you're going to have these fluctuations. So putting in at the very minimum at some of these breweries, pH neutralization to make sure your pH is fairly neutral. You may not even have to add acid or a caustic by the time you're done to get it out there and to comply with your industrial user local limit or your town sewer use ordinance. You want to try and have a neutral pH, obviously. And then again, I want to slowly wrap this up here as we start to talk about permitting strategies. This is really, goes back to you. Are you going to permit these high strength waste facilities as an SIU? Maybe. If they're an SIU, remember they need to be sampled, permitted, inspected at least once a year, monitoring data to the frequency that you put in the permit, etc. They must comply with all your local limits. There's another option. You could permit them as just an industrial user with lesser requirements if you feel like it's more, if they're a good actor or an actress. and you don't want to go out there on a yearly basis, etc. You could require BMPs, side streaming, which we just talked about, solids management, and then there's agreements or allocations. You know, if you're a small program and you're thinking, well, you know, the town manager or a city mayor or town mayor, whoever it is, the board, select board, etc., aldermen really don't want us to permit them, but we have this agreement in place to allocate X amount of a loading to the particular industry. Well, that's fine too, as long as they don't exceed that allocation, right? Because what happens when you exceed that allocation, and there's a potential for you to violate either an NPDES permit, or again, you come close to the 85% design capacity at the treatment plant. So, you know, just some things to think about as we shift gears a little bit into the development of maximum allowable headworks loading and local limits. This is a separate course completely on its own, so I'll hit it really quick. You know, the MAHL, it's really just using real data to back calculate in order to find an MAHL to determine the most stringent criteria, whether it be water quality, sludge quality, NPDES permit, worker health and safety, etc. You know, in a traditional setting, that's how it's done. But for BOD and TSS, when you develop maximum allowable headworks loading, you do use design loading at the POTW. You're not designing an MAHL for BOD or TSS based on the NPDES permit. If you design it based on the NPDES permit, it will be way overly too stringent. You need to use design loading at the treatment plant. So I ask you now, again, by a show of hands, how many people know what the design loading is at the treatment plant? And then how many people actually believe that your design loading that you think what it is truly accurate? Okay, because whatever your design loading is, or even design flow, what happens when you have heavy rain events? And for us in metropolitan areas, we have CSOs. And if your design is 10 mg, excuse me, your average flow is 10 mgd, your design is 20, but yet you've got 100 because we had a 4-inch rainstorm, but yet shockingly, you never violated your NPDES permit. So all good things to look at as you go through. And again, setting of local limits. There are no two POTWs that are going to have the exact same set of local limits. It's going to change all over the place. You know, they might be a little close, but they're not going to be identical. Okay, no two sets are alike, and no two industries should have just pie in the sky, arbitrary limits that are out there. So, you know, keep that in mind. And then lastly, when you are setting these local limits and you're doing the sampling, it must be representative. You have to have representative data. Current representative data is crucial here. And account for detention time across the treatment plant. Figure that out. You know, a typical activated sludge treatment plant, on average, again, don't quote me, on average, it's anywhere from 14 to 18, maybe 20 hours a day. Might be a little more, might be a little less, but it should be somewhere in there. It's not going to be 2 hours, I can tell you that, and it's not going to be 0. So if you're going to do 4 or 5 days of sampling, don't set your influent and effluent sampler up for the same time. Don't set the influent up at 5 o'clock or 7 o'clock on a Monday morning and the effluent at 7 o'clock on the same day, because you're not going to get an efficient removal efficiency. And removal efficiency is what really drives these local limits. By playing around with the removal efficiency just by a slight percentage is crucial. So very quickly, just giving you a case study here of a POTW, a 5.7 MGD design plant. I rounded the numbers up here just to give you something to go on, just to show you like what numbers would typically look at in a situation you might fall into. The design loading here for BOD, 16,000 pounds. You have uncontrolled waste, that's your residential waste, your background, small commercial, 10,000 pounds. And then you've got hauled waste. Don't forget about the hauled waste, unless, of course, you don't take septage and you don't take hauled waste, you don't have to worry about it. But in this case, we're going to account for the hauled waste. So we take our 16,000 pounds per day, and that's our MAHL. We're going to use a 10% safety factor. Again, you can use 15, you can use 20. I'm just using 10 here. That's your choice. Going to subtract off our 10,000 pounds of uncontrolled waste, our 1,500 pounds of hauled waste. and we're left with roughly 3,300 pounds. Some people even put a reserve or a safety factor on top of that for the sake of not being too difficult. I didn't do that, but some people put yet another safety factor in there. So we've got 3,300 pounds of BOD, and that particular industry has requested of the 3,300, they're requesting 2,400 pounds, so 72% of that. In TSS, they're requesting 4,000 of the 4,800 pounds. So it doesn't leave you much here from, if you're using this as an example, you've got only 950 pounds of BOD or 800 pounds of TSS left. That's for all the remaining industries. So when you talk about giving away a piece of the pie, and every time I think about this mass allocation or an allocation to industries, I then think of Marty Groom. And Marty, if you're listening out there, I don't know how many times I listen to you give that damn presentation about the pie. All it does is makes me hungry, and I need a slice of that apple pie. But the message here is Marty says, don't give away the pie. Okay, you have to keep a little piece of the pie. And Al has a nice slide about the pie. So don't give away the pie. And here you'd be giving away the whole pie to this one industry, and basically saying that you, in this example, if we use the brewery numbers here of 10,000 milligrams per liter, and an average brewery discharges 12,000 gallons of flow, that's it. That's all you could take from anybody from here on in. So basically, you're putting yourself in a bad position there. So highly encourage you not to give away the farm. But when and everything should all, when we're talking about BOD and TSS, it's all numbers created. If you're going to put in a permit, I highly encourage you to do it in pounds per day. Don't ever put BOD TSS limits in milligrams per liter. It always should be as MAHLs are, and always adopted into the sewer use ordinance. They should always be in pounds per day. So just some examples here with effective treatment, or here's a BOD, the first one there, 10,000 milligrams per liter at 40,000 gallons. You're up at 3,400 pounds per day. But if you, in this particular industry, if they cut the flow back by 40-fold, and yet they still doubled the BOD concentration, the pounds would be only 167 pounds per day. So more than likely, you're going to be in the third scenario. Here is a decent example of BOD of about 3,000 milligrams per liter at a flow of 5,000 gallons per day. Your pounds are going to be about 125. So lastly, I want to throw a couple of quick examples of what some permits look like. These are permits from breweries in New England. This first one in Vermont, the average flow from the POTW. So again, 237,000 gallons per day. That's a 0.2 million gallons a day. So a very small plant. And Rock Art Brewery is permitted for 3,300 gallons per day. They have a BOD local limit of 310 pounds per day. That's the equivalent at 3,300 gallons per day of 11,000 milligrams per liter at their max flow. If they cut their permitted flow back in half to 1,500 gallons per day, the SIU could basically discharge 25,000 milligrams per liter of BOD. And I've been to this facility. They have pH neutralization only. They don't need to put in anything beyond that. They just need to meet the pH local limits of whatever they are, because you know they're never going to exceed that BOD local limit of 310 pounds per day. So even though it's very small POTW, you know, they can handle it. So kudos to them. Another small program, 293,000 gallons per day. That's 0.29 million gallons per day. I started drinking at 9 o'clock this morning, so pardon me if I start to slur here. They're permitted for 4,400 gallons per day. The BOD pound per day limit is 11 pounds per day. That's the equivalent of 309 milligrams per liter. That's basically residential waste. That's background. That is incredibly stringent, and that's on Alchemist Brewery. But as you saw from the video, they took it upon themselves to say, hey, wait a minute, you know, we can even do better than that. We're going to discharge down to 0.2 milligrams per liter. So kudos to Alchemist for doing that. And then lastly but not least is Middlebury, the average flow of about 1 million gallons per day. This is Vermont hard cider. They're permitted for about 70,000. The BOD limit's 2,500. That's the equivalent of about 4,200 milligrams per liter. If you want to start to throw in the surcharge system, one of my last presentations, I said, what do you surcharge for for BOD, and they said 40 cents per pound, and I said, okay, I'll throw that into my equation here on my last slide. And so if you're operating at 261 days a year, you're not operating on the weekends, it's weekday only, at 40 cents a pound at max flow, that's $1,000 per day. How many industries, are willing to pay $1,000 per day to discharge to the sewer system? That's $261,000 per year. So, think about that as you go to the surcharge. So with that, I am going to turn it over to Al Garcia, and I hope that you found that worthwhile. If there are some questions, please put them in the chat box. Al's now going to share his screen and talk about some other examples, more case studies. And Al, hey, go Broncos this weekend. I'm the biggest Denver Bronco fan in the world this weekend. Stick it to the Chiefs, baby. Go Denver.
Yeah. Hey, thank you, Jay. I want to thank my good buddy Jay. Apparently he's trying to take us into happy hour for those of you on the East Coast. Great information, Jay. I appreciate the videos. Talking about pie and that bear dump that you had, man, it made me hungry and want to go to the restroom. So I appreciate just the information that you provided. Also, thank you to headquarters, for allowing us to present this information. So this picture, is there's a reason why the sunsets in Colorado are orange. Go Broncos. I agree that this also may be allegedly from the fires we're having out here in Colorado, but I always believe in Bronco orange sunsets. So Jay and I, really are champions of local communities, of municipalities' authority to protect their wastewater treatment plant. And so in the attachments, I just want to make sure I take care of that. In the attachments, we did provide a couple attachments, and one of them is an ordinance example that I provided to small municipalities in Region 8. Just to help them understand what sort of authorities they can provide in their legal ordinance, to be able to go out and do inspections, to have the right of entry, to develop best management practices, to help them, develop tools that they can use to protect the wastewater treatment plant. So there's that in there for you. And as a follow-up to this, I'm always available for anyone that has questions, to be able to understand what is the due diligence you need to have in order to develop that local authority for your municipality. Every municipality is different. And so there's tools in there that you can use, pick and choose on what would help you as far as protecting the wastewater treatment plant. Wastewater treatment plant, a PHW, a publicly owned treatment works, is not only the wastewater treatment plant, it's also the collection system. So there are some tools in there that you can use. There's also an attachment that we have as reference for local limits. So Jay had a great presentation about local limits and permitting strategies. This attachment provides you just some information that you can use to determine what sort of local limits, or even what sort of allocations, or basically even understanding what are your design loadings for your wastewater treatment plants. There's an attachment there that you can use too. And again, if you have any questions, we're available after this conference for questions and answers, or even any conversations you have as far as developing that legal authority in your municipality. So for high strength waste, these are some of the things that we talk about when we're discussing high strength waste. Conventional, non-conventional pollutants. And so for that first bullet, BOD, TSS, pH, fecal coliform, fats, oils, and greases, or FOG, phosphorus, nitrogen, with the new nutrient regulations come upon, and sulfides. These are high strength wastes that potentially could impact your wastewater treatment plant, your collection system. For food processing, slaughterhouses, dairies, and breweries, and even for smaller PHLBs, there's a lot of lagoons out here in Region 8, in the states in Region 8, where a high strength waste can be from a restaurant. It can be from truck to hauled waste, and Jay mentioned pass through and interference. And so the analogy that I always use is that, so allegedly when Jay and I, and also Paul Marshall from Region 7 was on the stage singing karaoke, we may have had some beers. Jay and Paul are used to having a couple beers, every once in a while, but we may or may not have more than a couple beers on that stage. So I guarantee you that night, for Jay and Paul, they did have some interference, and the next day there was some pass-through going on. So they're used to accommodating this high strength waste when it's mixed in with other waste. But when you have a batch discharge, or when you have a facility that comes into play, like a slaughterhouse, that gives you an increased loading of that high strength waste, that's when you start seeing this interference issue and pass-through issues. These are the concerns that we have, that you as a lagoon, you as a small treatment plant, you as a mechanical plant have those abilities and those tools to really control those, to minimize or eliminate the impacts to your wastewater treatment plant. So I'm going to go more the operational route and talk about, you know, just what are some of the alternatives to permitting? What are some of the alternatives best management practices that you can do in order to address this high strength waste? You know, and so as Jay mentioned, you know, what is your design loading? What is your design capacity for your PHW? When we talk about biochemical oxygen demand, for example, or BOD, there's really three things, and he kind of touched on some of those. You know, you really want to understand what is your particular wastewater treatment plant's design capacity for BOD removal. What are you engineered for? And these are engineered and financed for your residents. So that's the part of your wastewater treatment plant that you want to protect. What is the now in your service area? And again, every service area is different. What is the BOD loading coming to your plant from your service area? What are those pounds per day? What can you accommodate? What is your removal efficiency? And then what is the percentage of BOD loading that's available to your non-domestic sources? Again, protecting the residents part of it. So when Jay talked about that pie, we're talking about this, you know, so in your service area for BOD, for example, you have a design loading, a design capacity that your wastewater treatment plant is designed for. You really want to know what the loading is coming into your plant. And you want to start to then delineate, where does that come from? Does it come from the domestic side, the residents? You know, you do get some loading from the residents. You may get some loading from the truck and hauled waste, probably not in a portion of the pie this big, but this is the only pie that I was able to find that looked kind of cool. So you want to then determine what are these loadings coming into your plant, and then that yellow piece of the pie, you know, what is available, what's allocated to these non-domestic sources, what can you provide to them? And sure, you can definitely allocate these as limits, as Jay mentioned, in permits. You can, you know, you can definitely have BMPs based on these loadings, or you can use this as, you know, here's some strategies that I can use. Here's some methods that I can use to protect my treatment plant. Maybe not through pre-treatment specific sort of permits, but also some decisions that you can make. And so for surcharging, for example, you know, you can definitely surcharge high strength waste. You have that ability as long as you establish that authority in your ordinance. You can definitely, you know, offset the cost of treating this high strength waste, whether that's coming from restaurants, whether that's coming from any other of those high strength waste sources. What I recommend is that the municipality or the PHW determine what is that ceiling. So at what point of offsetting that cost does it become an impact? Does it start to interfere with your plant? Does it start to be an indicator of pass-through or violations of your NPDES permit? So limits or allocations, as Jay mentioned, you know, you can definitely do that for high strength waste, or you can start to determine, can you have some sort of alternative PHW operational methods or strategies? Can you start to divert that high strength waste? Can you receive that outside of the collection system, where it may be a benefit to your wastewater treatment plant and also provide some relief to some of the industrial users? So the diversion part of it is more of that win-win sort of strategy, both for the community and also for the PHW. So here's some of the benefits, you know, to the PHW. Again, protecting the treatment plant and the collection system from slug loading and discharges to your plant. It gives you that ability to, instead of passively receiving this sort of high strength waste, now you can actively manage the high strength waste and manage your influent loading. You can start to divert some of that high strength waste loadings coming to your plant from these non-domestic sources and really start to normalize your influent loading as it's coming to your plant, and then be able to predict, you know, what sort of treatment do you have to ensure that you have in order to treat this effectively. Again, protecting the wastewater treatment plant for the residents. You can manage the costs, you can assure compliance with the regulatory requirements, and then, you know, especially here in Region 8, where we have a lot of rural wastewater treatment plants, that may be the only game in town, so to speak. So if you have truck and hauled waste, for example, which I'll talk about in a case study, that may be the only place where they can discharge it. What if there's no alternative for them to discharge or dump their waste or be able to discharge to your treatment plant through a collection system? What's their alternative? You know, they're out in the rural areas. There may not be an alternative for them to discharge it. So a public health issue may be a benefit to the community, in addition to accepting this waste as a benefit to your wastewater treatment plant. So I'm trying to give some case studies that will apply to both the mechanicals, larger or medium-sized wastewater treatment plants, and also some truck and haul waste things that may apply to small lagoons and rural plants. So these are the cities that I interviewed, that I visited, that I've audited, and that provided information on how they address the management of high strength waste. And I have contacts at the end where you can follow up with some of the contacts at these cities. These guys are the experts. I'm just the conduit that's providing the information. They've done some really good things with the diversion of high strength waste. So thank you in advance to Colorado Springs, Fort Collins, Pueblo, and Casper. So let's start with Colorado Springs. So Colorado Springs is a mechanical plant. There's actually 2 wastewater treatment plants in Colorado Springs. This is the J.D. Phillips wastewater treatment plant. And just as an overview, it has headworks, grit removal at the very top of this slide. They have the primary sedimentation basins in the middle of the slide. They have biological nutrient removal aeration basins also located within it. At the bottom of the slide, you can see the primary clarification, where they have a return activated sludge going back to the biological nutrient removal basins, waste activated sludge that is then pumped to their other wastewater treatment plant. Their effluent coming off of their secondary clarifier is UV disinfected and discharged to Fountain Creek. And so this is the wastewater treatment plant where there is a local dairy within the service area where they have had some high strength waste that they were discharging. It's the whey waste, and they manufacture cottage cheese. And part of that is, you know, they curdle it, and then they have to rinse that cottage cheese and develop a whey waste, which is high in conventional loading. And the local dairy was paying a high cost for the surcharges, and they were trying to find an alternative. The engineers at Colorado Springs understood that, you know, that their wastewater treatment plant was carbon limited, and I'll talk a little bit for the next case study about the nutrient regulations that are in place in Colorado. The wastewater treatment plant was carbon limited, and they needed a carbon source in order to meet the nutrient regulations in their biological nutrient removal process. So the engineers at Colorado Springs actually contacted the dairy to see if they could accept their waste as a carbon source. They found out that this whey is a good source of lactic and acetic acids, which is really important as far as that carbon. That's that good carbon that helps you with the BNR process. So Colorado Springs had a pilot study. They did some bench testing and determined that yes, they can accept this whey waste, and they started contracting with the dairy. They received this whey waste in their grid basin tanks. This was an underground grid basin tank, and started receiving loading coming from the dairy at 5,000 gallons semi trucks. And so they offloaded that into this grid basin and started surge dosing that into the aeration basins. Again, they have a primary aeration basin going to the BNR basins. So they surge dosed that at 300 gallons an hour within 2 or 3 minutes. So it was a massive surge going to the primary sedimentation basin. They found that because this whey waste was in this underground tank, and it was at temperature, and it was getting a higher temperature, that there was some fermentation going on. They didn't realize that at the beginning, but the fermentation allowed the lactic acid that was in this whey waste to be converted over to acetic acid, which helped as far as the volatile fatty acids or the VFAs. So this fermentation discovery was by accident, but it was actually a good discovery that allowed them to determine that the surge dosing actually helped the BNR process. So they did some lab fermentation testing to determine, okay, what sort of temperature do we need to be at? What sort of pH adjustment can we do in order to increase this conversion from the lactic acid in whey waste over to more of this acetic acid, and found that through this bench testing that they're able to get VFAs at a concentration of 20,000 milligrams per liter, which was very helpful for the BNR process. They then converted over to full scale. They thought this is a great thing. We're going to make this permanent. So they paid some cost to construct 2 35,000 gallon underground dosing tanks in order to accept about 50,000 gallons a week from this dairy, and had some great benefits. You know, one is that it replaced the cost of them having to buy acetic acid. For the dairy, it was a great benefit to the dairy because it helped them to offset the cost of the surcharges. And for the city, it was a stable source of carbon, you know, so they thought they were set, and were able to help the plant process with the BNR with this good carbon source that was stable, and that provided them some real benefits. Well, then COVID-19 happened. So for the dairy, they had to decrease production, and they went from a good stable source of 20 trucks to about 3 to 4 trucks. So as a result, Colorado Springs had to supplement their carbon source and had to actually buy acetic acid. And it was a huge cost. You can see how much it costs as opposed to getting it, you know, at a contract basis from the dairy. So they're still working through those issues. And so Colorado Springs kind of had to adapt like we all have for COVID-19, and they're now looking for brewery waste. You know, there's a lot of breweries out here in Colorado. Colorado Springs has some great breweries, and I tried to visit as many of those as I could when I was there at Colorado Springs for an audit. They have some great breweries, but they're all smaller. And so they're trying to determine, can they have the same type of source from breweries that they're getting from this dairy, you know, just to protect themselves in case this pandemic continues to happen. They're also looking at their sludge blankets to ferment those, to again convert those over to a carbon source. So Colorado Springs is making that first effort into having a benefit to the community and also having a benefit to the wastewater treatment plant for this source. My next case study is Fort Collins. So kind of similar to Colorado Springs, Fort Collins has 2 wastewater treatment plants, or PHWs. This is the Drake PHW, and this one is a mechanical plant. It's a larger one. Again, there's a headworks, a grit removal, there's primary clarifiers up on top. It goes through the biological nutrient removal basins, secondary clarifiers at the bottom with return activated sludge going back to the BNR, waste activated sludge going to a DAFT. For thickening, and then also to anaerobic digesters. The effluent coming off of the secondary clarifier again is UV disinfected and discharged to the Cache La Puta River. So I mentioned the nutrient regulations. So in Colorado, they passed nutrient regulations about 4 years ago, which has total phosphorus at 1 milligram per liter for an annual median. And 2.5 as a 95 percentile over basically 12 months, the recent 12 months, for total inorganic nitrogen, annual median at 15 milligrams per liter and at 20. So there's some real regulations that are in play here, and so kind of similar to Colorado Springs, Fort Collins knew that they needed to convert their wastewater treatment plants from a trickling filter to activated sludge process to a biological nutrient removal. So in this situation, they changed their basins to what they call an ATO, which is anaerobic and an anoxic and an oxic zone. So the way the BNR works for them, it's really 3-stage. And so it's really curious to see the conversion of these aeration basins into BNR. So basically, for the first stage, you have the anaerobic basin, which it's devoid of oxygen and nitrates. There's some fermentation happening in here, kind of similar to what Colorado Springs and what they accidentally discovered in the grit basins. There's fermentation that breaks down the complex organic molecules, and it releases those volatile fatty acids, or those VFAs. The phosphorus accumulating organisms, or the PAOs, they compete with glycogen accumulating organisms, or GAOs. So the PAOs store the the volatile fatty acids, and they release phosphorus in the first stage, anaerobic stage. So that's where that phosphorus release happens. I'm going to jump over to the aerobic stage. In the aerobic stage, the phosphorus is uptaken by these PAOs that are in the aerobic stage. So they oxidize in the presence of oxygen. So this aerobic stage is aerated. And the PAOs oxidize the volatile fatty acids. They then have carbon oxidation and nitrification occurring, and then the phosphorus uptake occurs. Okay, and so these PAOs get really fat with this phosphorus in the aerobic section part of this. The mixed liquor suspended solid from the aerobic zone then is returned to the anoxic zone. The way the phosphorus is removed in this situation is that in the WAS or the waste activated sludge, the PAOs, the really fat organisms, are then wasted over to digestion, and that's why you get rid of the phosphorus. In the anoxic zone, this is where the denitrification occurs based on the return of the mixed liquor coming from this. This is where you have the denitrification and the nitrogen, the nitrates and nitrites are converted over to nitrogen gas, and it's released over to the atmosphere. So in this situation, you definitely need a carbon source. You know, and this is where a lot of wastewater treatment plants in Colorado are faced with. How are they going to get that carbon source? Are they going to pay for it, or are they going to try to find this carbon source within industrial users in the service area? So Fort Collins understood that the Drake wastewater treatment plant is carbon limited during certain times of the year. This is a rule of thumb engineering ratio of what's necessary for biological nutrient removal. You'll see the COD to BOD ratio, the COD to total Kjeldahl nitrogen ratio, and the COD to total phosphorus ratio. And you'll see that a Drake wastewater reclamation facility is carbon limited at 10:1. And so they knew that they needed carbon in order to meet effectively the BNR requirements to meet the regulations. So they used the pretreatment program to determine whether or not there's industrial users that have high strength BOD waste. They also evaluated, you know, what would it take for them to buy carbon sources in order to pay for it. They started to center in on breweries. So kind of similar to what Jay was talking about. They searched for carbon and they did some sampling of breweries at Fort Collins. And, you know, the type of waste that they looked at, they sampled all these type of waste, the post-anaerobic waste, treatment waste, spent yeast. They really centered in on trub waste. And trub waste is the, you know, it's a German term which mentions sediments, either coming out of the wort with the boiling called the hot break, or before primary fermentation boiling, which is called the cold break. You also have trub coming off of the fermentation vessels. So the trub waste is really what they centered in on. They did find a medium-sized brewery that shall remain unnamed, and contracted with them in order to bring waste to their plant that they can use as a carbon source. So they also did some bench testing and found out that there's these types of volatile fatty acids, or VFAs, in there that provided really good benefits to the biological nutrient removal process in their plant. They also did some studies on fermentation and found out that, you know, at the temperature of 30 degrees, it was the best and most efficient process in order to give them that carbon source that they needed. So they really wanted to have that acetic acid source, because that is the good candy carbon, as PHWs call it here in Colorado. So they knew that you know, in order to receive this waste, that it definitely helps with the nitrification. It's a good carbon source for these PAOs to help them uptake phosphorus. And they also knew that part of this pilot study is that they need to ferment this brewery waste. So in order to prepare for this, they needed to, kind of similar to what Colorado Springs did accidentally, find a fermentation vessel in order to surge dose this into their plant. So right now they're in the piloting phase, and they're looking at what does it cost to have these tanks in order to optimize the fermentation before they dose it into the BNRs. They're looking at surcharge fees, you know, because obviously if these breweries are going to provide this high strength waste, there should be an offset cost with the surcharge fees that they have currently with high strength waste. They're also looking at other sources of high strength waste and determining the benefits, you know. And for Fort Collins, you know, the conclusion I have from them is that this does provide a good benefit to the breweries for surcharging, and it also also provides good benefit for the wastewater treatment plant. So a win-win situation. Now, for some of the smaller plants, and I understand this is a mechanical plant, but these two case studies have to do with truck to hauled waste, and so this is Pueblo. Again, it's a mechanical plant, the traditional headworks, grit removal, primary clarifiers, BNR, secondary clarifiers, UV. The return activated sludge and waste activated sludge, anaerobic digesters. But I mean, it's kind of hard to see, but in the very middle of this presentation is the truck to hauled waste station. This is where they receive the truck to hauled waste, and then on the left side of that, on Stockyard Road, are their drying beds. So Pueblo used those drying beds to accept truck to hauled waste that normally would cause an impact to their plant. So their truck to hauled waste program issues permits on a one-year basis, and they require manifests. They are allowing mixed loads of gray grease and septic wastes. The septic doesn't cause them problems, but it's this gray grease that they have an issue with. So whenever they get mixed loads, the truck to hauled waste under their permits are required to report to the office, to show the manifest to the operator, and the operator can determine on a case-by-case basis if they can accept it or if they have to go to the drying beds. Here's a picture of the septic station. It's right in front of the operation. So when they drive in, they can drive up and discharge their septic. And here's a picture of a trucker actually discharging it. I guarantee you, man, I'm glad I went to college. So this would be a tough job, but this is a great benefit to the community when they are able to bring this waste. Behind this truck, you can kind of see all the drying beds behind those trees. This is where they would have to go in order to discharge the gray grease coming off of the restaurants. Pueblo also accepts the sand interceptor waste from car washes and automotive shops. And this is not limited to the service area. So they're providing the service for outside of the city, outside of the county. And so, you know, they're providing that service again. Just east of Pueblo is a lot of rural areas that they may not have a place to go with the sand interceptor or car wash waste. So, you know, the same thing as with the septic and the gray grease, they have to go into the service area, they have to go into the office, they have to provide manifest, and then they're able to unload to those drying beds. There's 4 cells that Pueblo has, and they charge $60 per load. That's basically their cost to maintain that and to send it over to the landfill. So they're not making money off it. They're just providing that service for sand interceptor waste, which I know for the community is a really great benefit. It's not impacting the plant. Casper, Wyoming, and so I have a couple minutes left, so I'm going to go through this too. Casper, Wyoming. You'll see on the left side of Casper, Wyoming are the drying beds. A typical mechanical plant coming through, the drying beds on the left. So in 1988, Casper, Wyoming, again, they're up in Wyoming, a lot of small open space around them. They initiated the acceptance of industrial waste. So they have a lot of sumps that they're required for oil and gas facilities and car washes and automotive shops, those type of facilities. They allowed them to come to their plant with this truck to haul waste because they knew that the alternative was for them individually to try to figure out what the hell are they going to do with this waste they have in their sumps, their sand interceptors that they collect from their process. So they accepted that waste to go to the drying beds. They have about 75 sources within the city. Every year they require TCLP tests and the issue of manifest number. Kind of similar to what we talked about with Pueblo. They have to verify that manifest at the operator's office before they're able to discharge that. They started off with 1 drying bed, and the drying bed had a capacity of 2,000 gallons per day. They've since opened that up to 12 beds and are able to get 12,000 gallons per day. And what they do in those drying beds, and I have some pictures a bit later, they're able to rotate these drying beds to dry out and then also to evaporate and then to collect them and put them into a truck to send to the landfill. So 2019, they accepted 365,000 gallons of industrial waste from the community. We don't know, you know, and again, if they didn't have this available, because this may cause an impact to the plant, but if they didn't accept it, we don't know what would happen to this 365,000 gallons of industrial waste. So it's very successful for them and also for the community. 2011, they started accepting fog from grease interceptors and open up the drying beds to accept fog. They charge 300 gallons or $300 per 1,000 gallons in order to accept these type of wastes. And again, that's basically the cost of them to maintain it and send it over to the landfill. So for the oil and grease program, they do accept this grease outside of the county, which is a benefit to the community. They have to come in for a sample and pH test. They have 6 drying beds that they rotate. The difference between industrial waste and this fog is that they add lime to stabilize that, and then they allow that to dry and evaporate. And kind of similar to, they mix it, they dry it, and then they scoop it up and put it and send it to the landfill. And 450,000 gallons of fog that they receive annually at the wastewater treatment plant. Again, great benefit to the community, because who knows what these restaurants will do individually with those, or the truck haul waste. Where would they go to if they have no chance to go to Casper? So here's a picture of their drying beds. On the left side is the industrial drying bed. On the right side is the fog drying bed. This is a great picture of a truck unloading industrial waste to this drying bed. They just drive right in, unload it, and drive right out. This is a picture of a fog drying bed, and you know, it doesn't necessarily smell that great, but it does it does allow some time for drying and evaporation. This is dried industrial waste in that drying bed, and then here is the fog. They've added lime to it, and they're letting it dry in order to transport that to the landfill. Here's a picture of them actually scooping it up into a truck to send to the landfill. So besides these 4 case studies, you know, and again, so Jay and I aren't the experts. The people in the community are the experts. You know, there's information at WRF. There's information from consultants that you can use in order to determine what you can do to protect your wastewater treatment plant. But some other methods that I've heard about, and some in Region 8, where they accept fog. They accept fog and high strength hazardous waste into the digesters for co-digestion. That'll help just limit that whole liquid stream. They put it right into the digesters. And again, you also have to know what your design capacity and your loading capacity is for your digesters, so you don't contribute to foaming. But there is that ability, if you have digestion, to accept this type of high strength waste. These are the contacts, and I appreciate the information that they provided from Colorado Springs, Fort Collins, Pueblo, and Casper. And this is in the attachments that you can use to give them a call and ask them about some of their specific strategies that they had. And thank you to all of them, to Bill, Jason, Andra, and Randy. I appreciate the information very much. And I'm done. So wanted to open it up to see if anyone had any questions. Jay, do you want to get back on?
Yeah, thanks, Al. I see that Jan has done a great job in answering a lot of the questions that have already come in, probably 90% of the questions. So thank you, Jan, for taking care of that. There was one question about, can you describe side streaming a little bit more in depth? And so we'll take a crack at that. Side streaming, is pointed out in the video, is basically collecting your high strength concentrated waste at the source itself and setting it aside for proper disposal. So you're physically taking the solids out of, like in a dairy process, at the beginning step, say the mash tun, right after you have the milling, and you have milling, and then you add the water to it and any other ingredients, and then you filter out the water and go over into the next step in the brewery process. But you have this large tank that's basically full of spent grain or spent solids. So it's physically taking those solids out of the tank and putting them in drums or totes and sending them off directly for disposal. It's not sending it back to any other treatment. There's no treatment. You're just taking that waste, putting it to the side, and then again, spreading it for solids or spent grain, sending it out and using that as a cattle feed or a land application, etc. So that's basically the side stream operation.
Yeah, and then to follow up on that, so in Colorado Springs and Fort Collins, so Fort Collins, they are side streaming at that brewery. They have one tank where they have collected all their waste. Then Fort Collins comes in with a truck and then picks it up and uses it in their plant. Same thing at Colorado Springs with that dairy. They're side streaming their whey waste, collecting it into a large tank, which makes it easier to offload into those 5,000 gallon semi trucks to bring to the wastewater treatment plant. So the diversion is the benefit of side streaming.
Yeah, I'm going through trying to monitor this Q&A. Here's a question of how does lime affect the plant? Is lime caustic or acid? Yes, lime is a caustic. It also helps with vector attraction if you're land applying any sludge, etc. But lime is on the caustic side.
Yeah, and the lime in this situation for Casper is used in the drying beds. It's not used in the plant. It's not used in the liquid aspects of it. It's used in the drying beds, and then it's hauled off to the landfill.
Yeah. There was a question about what type of treatment is best for breweries. Again, there's no one go-to treatment in place, but certainly in order to remove a lot of the solids and even the BOD, some form of clarification, typically a dissolved air flotation system would work, or again, some type of clarifier in order to settle out the solids, because that's really where you're going to capture a lot of your removal process. And whether it be, again, be a dairy or a brewery or a slaughterhouse, etc.
Yeah, Jay talked about pollution prevention too. So that's an important aspect for some of the nano breweries, where there's, it's not cost effective for them to be in business and have this large wastewater treatment, so removing solids, having an equalization collection vessel for their CIP and their high acidic or the caustic wastes. If there's a place that they can find it, that's some of the best management practices or pollution prevention that they can do also.
Yeah, and Mark from Carlisle, Pennsylvania just chimed in here and said a dairy and butter plant in Carlisle uses the DAF unit to remove the butter fat as well. So,
Nice.
it seems like that's probably the go-to. We're not going to recommend any particular manufacturers, or again, probably shouldn't be recommending any particular treatment in place, but it seems to be that's fairly common across the industry. Jan, are there any other outstanding questions here? There's a lot of comments that have come in, and again, thank you for taking the time to answer a lot of these questions here.
Let's see, I'm going through them, and a lot of them you answered during the presentation. Hi, y'all.
Yes.
A lot of them, some were site specific, and some of them people were on target to ask a question, and then the next slide basically was on target with the actual topic. So you guys delivered on what questions would be asked right with the very next slide.
Yeah, so if you want to know the outcome of the game on Sunday, be Denver 28, Chiefs 7. They'll be lucky if they get a touchdown.
So Jan, there's some new questions coming in.
Yes, questions are coming in rapidly right now. There was a question on what is there a correlation between BOD and COD, which is a bit beyond this entire discussion, but it's rather fundamental to knowing what pollutants to monitor when you're trying to assess the impact of these types of conventional industrial facilities. So which one of you want to talk a little bit about what BOD is and what COD is?
Al, you want to go, or else I will.
Yeah, there's I used to work in a lab before I went to pre-treatment, and there is some relationship to the values. I've always used COD as sort of that quick and dirty sort of test in order to determine what the BOD, but they're both a measurement of the chemicals and the amount of oxygen that's required for the bacteria to degrade the wastewater treatment plant. Is there any further specifics that you would like to add on to, Jay?
No, no, I mean, again, the BOD is measuring the amount of dissolved oxygen that's needed to meet the demand, basically to break down the aerobic biological organisms, so that those organisms can decompose, and then the chemical, a COD is the chemical oxygen demand. It basically measures the total measurement of all the chemicals in the water that need to be oxidized.
Yeah, so COD, it also, for organic and inorganic constituents, whereas BOD is, is the organic part of it.
And they're really measuring different aspects of a wastewater chemistry.
Yeah. There's a question here about how much BOD can a brewery remove from their waste stream with efficient side streaming. I showed a slide on that. It was actually from brewerywaste.com or wastebrewery.com that showed the difference with effective side streaming, and it's going to depend on you as an industry makeup, but it's pretty effective. So go back to the slide in my presentation, Rachel.
We have received many requests to talk about landfill leachate, and I will comment that landfill leachate, similar to these other facilities we've been talking about today, can be quite unique depending upon which landfill you just sampled from. And are you talking a construction debris landfill? Are you talking a municipal waste landfill? And so we have noted that down as a potential additional topic, perhaps for a future webcast. They're very hard to generalize. Let's see, we're still scrolling here. Just as a reminder, there are 5 handouts that are available, and one of them includes biographical information of your speakers. And if you want CEU credits, you need to talk to your respective state and operator licensing authority, and they often request copies of the bios of the speakers, and so that's one reason why that is there. Also, as Al previous stated, that he has provided a non-approved POTW program sewer use ordinance, meaning an ordinance or legal authority that a POTW might want to entertain if it doesn't have a full pretreatment program. That's one of the handouts. Another handout is the technical assistant webinar schedule. More webinars in the future if you'd like to listen to some, as well as ones that have already been conducted and are available for viewing in their recorded capacity. Also, some excerpts from existing regulation and existing guidance manuals that talk about how to set limits and to assess your treatment plant for conventional waste. Let's see. There are other questions, because lots of questions are coming in.
Yeah, I see there's a lot of recommendations for other types of webinars here. So your questions or comment, not so much questions, your comments are noted regarding the landfill leachate and others. So we do thank you for all the questions and comments that are coming in.
There's a question too about odor complaints on all of these different type of facilities that have high conventionals, and if there's odors due to the facility versus odors due to the wastewater, and additional questions on how you deal with that. Either one of you want to talk more about odors? It's not really in our wastewater regulation, but is often one of those side issues that doing treatment can help address.
Well, clearly having odors is a sign that you have something wrong with your system. Clearly, we'd like to think that you're never going to have odors. Odors are expected at a wastewater treatment plant, but odors should be minimal at best from any dairy, slaughterhouse, etc. Again, odors are typically a sign of a problem at the treatment plant and should be avoided at all costs.
One way I always think about it is if you have a fish that smells really fishy, that's something, don't eat it.
Yeah, you know, there are some odors coming out of a wastewater treatment plant. That's just the nature of it. You know, when I was buying a house, I made sure that it lived next to an airport or next to a wastewater treatment plant. But you know, there are some operational you know, there are some operational controls that you can do to minimize odor, whether you cover your clarifiers or your basins. You know, that'll help to minimize odors. But you know, for the city of Casper, when they have the drying beds, luckily that wastewater treatment plant is located in an industrial area, and there's minimal, if any, sort of representation from the residential sector. But those are things to keep in mind, is that there is an odor issue with the receiving truck to haul waste. Does that offset the benefit of the community for that receipt of it?
Jan, while you're looking at questions, let me do the closing couple of comments, and then we'll continue for those that want to hold on. So we're 15 minutes beyond our normal time, and there's just a couple of things I want to mention so that we don't lose the people. I know one thing that Laura wanted me to make sure I mentioned was that look for your certificate of participation tomorrow, 24 hours after the webinar. You should get an email, and there should be a link there and that you'll use to confirm your attendance here. So make sure you look for that. We often get emails following the webinars months, weeks later saying, I didn't receive this, I didn't see this. So please make sure you check your emails if you need that, and it will be coming in. And thank you, Jan, for going over the attachments. That was very important. And while we're answering questions, and I'll stay on a little bit long, we'll still continue to answer questions, but know you can download that now, because once we close out the webinar, you'll have to ask us for that. We'd prefer you to download them yourselves at this point. I'm also going to talk about the next webinar that's coming up. That is scheduled for November 17th. It's microbiology of wastewater treatment, life in aeration tanks, bacteria, protozoa, and metazoa. That'll be presented by John Van Domelen, Ohio Compliance Assistance Unit. That's the main things I wanted to get out here before we continued and lost some people, as some people are drifting off, I'm noticing, based on the number count. So also not thank everybody that's helped out, Al and Jay, thank you, and as well as Jan and Rebecca and Laura for helping coordinate the webinar. But let's continue with the questions now, and we'll move forward as long as the speakers and Jan want to go through the questions. So please move forward.
Yeah, the questions seem to be tapering off here as attendees as well. I'll answer one more here, and then I don't know when you want to wrap it up, but there's a question from David Freed about when considering BOD and TSS loadings from potential user, how important is it to sample the influent hauled septage separately? It has POTW, the hauled septage receiving station is just upstream from the influent sampling location. So the influent samples also represent the hauled waste well. So yes, you want to sample wherever your headworks is. If you're considering the influent, your influent and your hauled waste is separate, the influent should include the hauled waste stream. Other than that, you're not going to get effective removal efficiencies across the wastewater treatment plant. And in fact, unless you could potentially, I'd like to think not, but get higher a negative removal efficiency if you're introducing waste streams after the influent sampling. So I hope that helps. Peter, I think Jan's kind of answered most of the questions here. Do you, you've wrapped it up a little bit. Do you want to put the final wrap up here? There aren't many more questions that we haven't answered either live or through the Q&A here.
Okay, great. No, I think you guys did a wonderful job. It was great listening to hear you guys present and going through the questions. Thank you, Rebecca and Jan. We will end the recording now, and I'll keep the webinar open just for another 5 minutes. If you need to download anything, just do it now so that you will be able to take advantage of the presenters' attachments as well as the presentation. And with that said, I'll be ending the recording of the webinar, at least at this point.